Alright, so up until now I've explained to you a bit about what a pointer is. Now I'm going to show you how to actually create a pointer and how you can begin using pointers. In the previous lesson, you learned that it is possible to create variables that are designed to hold memory addresses, which are called pointers. In this lesson, we are going to explore how to create this variable. As we discussed, every memory address is the same regardless of what kind of data it contains. However, different data types occupy a different number of bytes in memory. For example, characters occupy 1 byte, a short int might occupy 2 bytes, a normal integer might occupy 4 bytes, and so on. Let's look at the way an unsigned short int might be stored in our 16-byte RAM example. In this case, we are going to assume that an unsigned short int takes up 2 bytes. So first of all, let's imagine this code. Short int, total equals 52. Okay. So we have stated that the variable named total is going to contain a value of 50,250. How would this look in binary? Well, I'll save you the process of doing the math and I'll just write it out for you. It's going to take 2 bytes to store that value because it's so large. That's why I chose a value that was so large. And this is how that value is represented. Now the reason why is because remember that you're going to start at the 1's place, then the 2's place, and so on. By the time you get over here, this is actually the place of 32,768 because that is what 2 to the power of 15 is equal to. And then of course you add up the different place values. You can do that if you want, but it's unnecessary. Just understand that this is the binary sequence to store this particular value. So remember that this particular unsigned short integer takes up 2 bytes. Therefore, how would it be represented in RAM? Let's store it at position 8 and see what happens. So here's position 8, here's position 9, and that's all we're going to look at. Let's start by just setting each one to all zeros. And now we're going to imagine that we're going to store this value at this memory address. So what we're going to have to do, because this takes up 2 bytes, and we can't put 2 bytes at one location, we're going to have to split it into parts. So first of all, we're going to put the first byte here, and then we're going to take the second byte and put it here. So this is how the variable total is going to actually be stored at position 8 in RAM. So notice that even though it's being stored at position 8 in RAM, it's actually getting stored at both position 8 and position 9. But we're just going to remember position 8 is where it starts. What I want you to notice is that obtaining the 8 bits at position 8 is not enough to obtain the full value in this example, but it is enough to start with. If we know that the unsigned short int starts at position 8, then we know enough to get a value. We just have to remember to grab 16 bits, not just 8 bits. As you can see, you will get very different results if you expect there to be 8 bits as opposed to 16 bits. You'll get a totally different number. If you know that your value is stored here, and you don't know that it's 2 bytes in size, and you grab the value that's stored here, you're going to grab the wrong value. You need to know that the value is stored here and it occupies 2 bytes in order to be able to grab the entire value. In an earlier example, I asked you, what is the value stored at a particular memory address? So for example, what is stored at the memory address 8? And you can look at this and you can say 11000100. But you can see now that this is not enough. I need to really be more specific and say, what is the 16-bit value stored at memory address 8? Okay, so now let's go on. You do not create a pointer only to store a memory address, but in order to give you a way to see and work with the data that is at that memory address. For example, it would be utterly useless if I were to create a pointer to location position 8 in RAM and have no method by which I could say what is at that location. So in other words, if I have a variable that stores this value, but I don't have any way to actually obtain what is at that value, then there's no use, there's no purpose to that. When you create a pointer, you must specify how big the data is that you are planning to use the pointer for. In other words, you must specify the data type that you are planning to use the pointer for. If you are planning to use the pointer to look at ASCII characters in memory, then you need to specify, I plan to use this pointer for the data type char, for character. If you are planning to use the pointer to look at data of type unsigned short int, then you must specify, I plan to use this pointer to look at data that is going to be unsigned short int. Whenever you create a pointer, you must specify the data type for what it will be pointing to. Now there is one more detail we have not yet covered. How do you tell a programming language like C that you want to create a pointer? Every programming language is different, but in C, all you do in order to create a pointer is you put an asterisk like this in front of the variable name. That's it. So to recap that, to create a pointer in C, you simply put an asterisk in front of the name of the variable. I'll show you how this works. So if, for example, I want to create a pointer that is going to be used to look at memory addresses that contain an integer, I would do this. Don't worry if you're confused. I'm going to explain this. First of all, notice the asterisk. The asterisk says that I am creating a pointer. If I had written int my pointer, then I'm creating an integer. I'm saying I'm creating a variable called my pointer that is going to contain what? It's going to contain an integer. Here, what I'm doing is I am creating a variable called my pointer that is going to contain a memory address, not an integer. My pointer is a variable that is going to contain a memory address. However, I'm specifying that what is located at that memory address is going to be an integer. So in our example here, let's just say this was an unsigned short int. Then at position 8, we're going to have, let's say, the start of the value. And at position 9, we're going to have the rest of the value, let's say. So what I'm doing is I'm creating a variable called my pointer, which in this case is going to contain the value of 8, because it is a variable that is designed to contain a memory address. This part right here, the part that I've highlighted, specifies that this is going to be a pointer that is therefore going to contain a memory address. This part specifies what is at that memory address. I'm saying that my pointer is going to point to a memory address, and whatever is located at that memory address I want treated as an unsigned short int. Now, let's go on. So, one more thing. When I write this code, and I'm saying I'm creating a variable called myPointer, which is going to contain a memory address, and at that memory address I expect there to be an integer, there are several ways that I can write this same line of code. I could write it like I just showed you, or I could write it like this, or I could write it like this. The position of the asterisk is not important, and you'll see it done in each of these ways. It's the same thing. The spacing is not important. In every case, you are creating a variable that is a pointer. That's what the asterisk means. And it's going to point to a memory address containing an integer. So, with any of these, I've created a pointer. So let's look at this line of code. Here I've created a pointer called myPointer. What data type do I expect it to point to? If you said integer, you are correct. Now, why did I have to specify a data type? Why can't I just leave that blank and just say I'm creating a variable called myPointer that contains a memory address? The reason you have to specify a data type is because later on, when I want to say what is at that location, I need to know how much data from that location I'm going to look at. 1 byte, 2 bytes, or more. And I need to know how I'm going to treat that data. If it's going to be a character or a number or so on. So you must always specify what you expect at that memory address. In this case, I expect an integer there. So one more thing I want to cover, which is what is the memory address that is now stored in this variable? The answer is we haven't stored a memory address there yet. We've merely created the pointer that we can later on give a memory address to. So whenever you create a pointer like this, you have not told it where to point. You've just created a variable that is going to hold a memory address. So let's summarize the entire lesson by saying this. When you create a pointer, you give it a data type, then an asterisk, then a name. And that's all you need to do in order to create a pointer. So if I say char, my char pointer, and I put the asterisk, there you go. I've now created a pointer that is called my char pointer. It is going to contain not a character, it is going to contain a memory address, and whatever is at that memory address is going to be treated as a character. So we're going to get into this a little bit more in the next lessons. All I want you to understand right now is that you can create a variable that holds a memory address. This kind of variable is called a pointer because it points to a memory address. The way you create a pointer is by specifying the data type, an asterisk, and a name. So if I want to create a pointer of type integer, I write int, and then I put an asterisk, and then I give it a name. Whatever I want to call the pointer. And that's how you do it. If I want to create a pointer that is going to point to an unsigned short int, that's how to do it. Remember, I haven't given the memory address yet. I've only created a variable that can hold a memory address. So we'll cover this more in the next lesson. If you have any questions, feel free to ask.